All right. Welcome everyone to the keynote for this AI and Democracy Hackathon, where we're aiming to demonstrate some concrete threats to democracy from AI, predict how this threat might look in the future, and try to come up with concrete measures to prevent them. With us today, I have the great honor of introducing Alice Gatti as a keynote speaker. She is currently a research engineer at the Center for AI Safety, one of the foremost labs in AGI safety and security research today. And she has previously worked on high-performance compute optimization in a postdoc with the Berkeley lab after moving to the Bay Area in 2020. So today we'll hear from her involvement in the project with her colleagues at the Center for AI Safety on the weapons of mass destruction proxy benchmark. And afterwards, I'll give an introduction to the weekend's exciting schedule for everyone joining us for the hackathon. So thank you very much for joining us, everyone. And without further ado, let's give it up for Alice.
Yeah, thank you for the introduction. It's very exciting to be here at the hackathon and to presenting my one of our latest project, that is the WMDP benchmark, where we focus on measuring and reducing malicious use of large language model with unlearning techniques. And we have been recently notified that the paper has been accepted to ICML 2024. So the work will be also presented at the conference in Vienna in July. Before diving into the details of the project, I will just briefly talk about the Center for AI Safety for who doesn't know about the organization. So Center for AI Safety, or CAIS, is a research and field building nonprofit organization based in San Francisco. And as you might guess, the mission is to reduce societal scale risks that can come from AI. And we do this through technical research by building the field of AI safety research, and then by doing advocacy for safety standards. And if you want to learn more about what we do, please visit the website safe.ai. Okay, so for today, this is the outline. So I will give an overview and a motivation for the project, then talk about the WMDP benchmark, and then I will move to an unlearning method that we developed. It's called representation misdirection for unlearning, or RMU. And then I will conclude with open problems and next steps. So first of all, what is WMDP? WMDP stands for Weapons of Mass Destruction Proxy, and I will explain a bit later the name. But basically, it's a dataset containing more than 3,000 questions that are multiple choice about biosecurity, cybersecurity, and chemical security. And here you can see some of the topics that are covered by the questions in the benchmark. So for example, for biosecurity, we have bioweapons, bioterrorism, viral vector research, or dual-use virology. Or for cybersecurity, we have, for example, reconnaissance, exploitation, and weaponization. And for chemical security, some topics are synthesis, purification, or bypassing detection. So this is a very big benchmark containing several questions about these topics. And why do we need this kind of benchmarks and data sets? So we know that AI models are really widespread into society, and they can do really amazing things, but they can also be used for malicious purposes, of course. And one of the main concerns is AI models helping users to develop bio, cyber, and chemical attacks. And the concern is so serious that the White House issued an executive order last October that calls for investigating how AI models can assist users in developing weapons of mass destruction. And this already gives an intuition for the name of the project. And so far, there is no unifying open source framework to test and reduce malicious use of large language models. For example, on the evaluation side, companies perform their own evaluations, but most of the time the results stay private, so the public cannot access to these evaluations. And also they focus on limited risk pathways. And on the mitigation side, like the main techniques now is to teach AI models to refuse harmful requests. But we know that sometimes it's not too hard to bypass these safety filters by adversarial attacks. So one of the ideas is that if an AI model doesn't have a knowledge about a topic at all, then it cannot answer questions about the topics, even if the user tries to force the model. So the risk mitigation strategy that we have in mind with this project is to start from your favorite large language model. It can be a base pre-trained or chat, open or closed source. And of course, for closed source models, it's the provider that needs to do the intervention. So we start from large language models, then we perform unlearning of harmful domains. And by this, I mean we make the model forget about knowledge of harmful domains. And here I list some of the domains that are covered by the benchmark. For example, historical bioweapons, gain-of-function research, exploitations or vulnerability discovery in cybersecurity or chemical synthesis. Now that the model doesn't have this knowledge anymore, it's ready to be served to users and it should safe to use. So this is a bit like the motivation and the risk mitigation strategies that we have in mind. So a bit more details about the benchmark itself. So again, the WMDP benchmark is like the name is Weapons of Mass Destruction Proxy, and is an automatic open source benchmark of hazardous capabilities in bio, cyber, and chemical securities that serves as a proxy measurement for hazardous knowledge. And here, the word proxy is very important because in the benchmark, we cannot include hazardous questions directly. That will be very bad. So the questions have been designed as a proxy measurement for this hazardous knowledge. And this is very hard to do. And indeed, all the questions were written by experts, academics, and consultants. And basically, what they did is to design threat models that can help in the development of bio, cyber, and chemical attacks. And they designed questions based on these threat models. And let me just stress that WMDP doesn't contain info hazards, and that's why we need the proxy word at the end. So there is no hazardous knowledge in that, and the experts focus on instead of precursors, neighbors, and components of bio, cyber, and chemical attacks. So, for example, for biosecurity, here if we look at the diagram on the left, it's totally fine to have knowledge about microbiology, bacteria, and viruses, but when we start to talk about anthrax or influenza or pandemic pathogens, then it starts to be a bit tricky. And this knowledge can help, it's a precursor and can help in developing a bio attack, but it's not enough itself to do that. So the experts focus on this yellow tier of knowledge. And similarly for chemical, there are different topics, and for each topics, one can choose questions with different level of hazard. And the expert focus on not the green one are the ones that are fine, maybe general chemistry questions like high school chemistry, and while in the yellow one, the level of hazard increase a bit, but it's still not info hazardous. So they focus on this yellow tier of knowledge. While for cybersecurity, one of the strategy was to focus on components of cyber attacks, for example, payloads or a trigger mechanism or infection mechanisms. So this is a bit like the strategy that experts use to design questions about the questions that can serve as a measurement for hazardous knowledge without being hazardous themselves. And these are some examples of questions that are in the dataset. So On the left, we have a question about biosecurity, in the middle about cybersecurity, and on the right, a question about chemical security. And these are very technical and very precise questions. And okay, so now that we have our data set that can measure the amount of hazardous knowledge that a large language model has, what we did is to develop a method that we call representation misdirection for unlearning, or RMU in short. And the goal here is to develop a method that reduces the ability to answer questions about harmful knowledge, but at the same time, like retaining the ability to answer questions about non-harmful knowledge. So about we want the models to be able to answer like general questions or questions that are totally fine to answer. So some examples of questions that we don't want the model to be able to answer are, for example, how to engineer an influenza virus to be more virulent, or how to synthesize anthrax, or how to develop an exploit to conduct espionage. So these are just some example of harmful questions that shouldn't be answered. And the idea of RMU is to act at the level of the representations of the data that we want to forget. So the idea is to perturb the hidden representations on harmful data, so the data that we want to forget, and at the same time preserving the representation on data that we want to retain, on benign data. In order to do that, we need two corpora. One is a corpus of knowledge that we want to forget, and the other one of knowledge that we want to retain. For example, for bio, the corpus of knowledge to forget is made of several PubMed papers that explain research about one of the topics that mentioned before, for example, gain of function research. While as a retain dataset, we use the Wikipedia text that has like a lot of general knowledge, and it's a good dataset to retain general knowledge. So we have these two corpora, and we take the model that we want to, we take the large language model that we want to unlearn, and we optimize some of its parameters according to a loss function that is made of two terms, the forget loss and the retain loss. So on the left, we have like a diagram for the forget loss. For the forget loss, we try to push the hidden representation towards a random direction. So like in the faded blue direction is the original one. The blue one is the one, are the representations of the models of the model that has been unlearned. At the beginning, these like two are the same, but while we optimize while we change the parameters, this representation will be pushed to this random direction. And at the same time, for the retain dataset, we want that the representation don't change at all. So here we, like this loss function tries to keep the representation on the knowledge to be retained as close as possible. So there is this tension between data to forget and to retain, and like these activations, some of them should move a lot towards a random direction, while some of them should stay as close as possible to the original one. And then we weight the retain loss with this coefficient alpha. This explains a bit like the RMU method that we develop, and I will show some results. We tested this method on 3 different large language models. We tested Zephyr, 7B beta, we tested Mixtral, and Yi 34B, that when we did the experiments were probably the best performant models. And here I report like the accuracy scores and the scores on empty bench. So starting from the left, like the blue columns represent the accuracy, so the ratio of questions that were answered correctly. On WMDP bio, so the part of WMDP related to biosecurity, WMDP cyber, so the part related to cybersecurity, and on MMLU. MMLU is a very popular benchmark to test general knowledge of large language models, and it contains several multiple choice questions about many different categories, from high school math to chemistry, religion, economics. So it's really a broad spectrum of questions. And we see that for the blue columns that are for the base model, like the score are certain level, but for the unlearned model, so the model after we apply RMU, and in like the light blue columns, the accuracy drops by a big amount on WMDP bio and WMDP cyber, and it drops almost to this dashed line that represents random chance, 25%, since we have every question has 4 possible answers. So we see like a drop in the performance on WMDP, while if we check MMLU, we see that the score drops just by a little, and this means that the general knowledge is overall preserved, while the knowledge tested by WMDP is reduced by a big amount. And another benchmark that is interesting to see is the MT bench. This benchmark tests like general conversational abilities of chat models. And here we see that the base model and the unlearned models have similar score. There is a small drop for unlearned models, but overall the conversational abilities are retained. And this is important because we don't want the model to be completely broken on other topics than the forget one. And yeah, now I think it's interesting to see some outputs of unlearned models. Here, there are some 2 questions that I showed before. One is about engineering influenza virus, and the other one is about developing an exploit for espionage. These are the answers of the base Zephyr model, and we see that for cyber, it starts to answer this question, and then I cut the answer here. And also for bio, Zephyr starts to say that it's dangerous and many other things. And this is the answer of the unlearned Zephyr. And yeah, we see that the answers are a bit strange. Basically, there are many symbols, character, words that seem random. And this, on one hand, is good because the model is not answering anymore to these questions. But on the other hand, we would like a fluent output even on topics that the model doesn't have knowledge about. So for example, here we would like the model to say something still fluent, even completely unrelated or random, but still that makes sense. And so I'll conclude with some open problems and next steps for the project. The first one is, of course, can you recover knowledge from these unlearned models? We know that models unlearned with RMU are weak to fine-tuning. And by this, I mean that if you take a suited corpus and you fine-tune on this corpus, you are able to get some knowledge back. And then a follow-up question would be, can you recover knowledge without fine-tuning on a corpus, or with other techniques? That would be it's also very interesting. And another question that comes from the outputs that we have seen in the previous slides, we've seen that the output is really is bad, it's basically gibberish. Is it possible to improve that? So is it possible to have a fluent output even on like forget topics? And yeah, another question that that comes from some observations that we have is the following. So we notice that the knowledge on topics that are close to the forget topic but not the same are also affected by unlearned techniques. So for example, for biology, for biosecurity, we saw that also questions about general virology are affected by this, and the accuracy on general virology questions also drops by a big amount. And so this is not desirable, because we would like the model to be able to answer questions that are fine, and that general virology questions are perfectly fine to answer. They are not harmful. So is it possible to retain as much as possible the knowledge close to forget topics? And some ways to improve that could be, for example, making the model less aggressive. Maybe the model is too aggressive and we damage too much, or maybe the data set can be improved. In general, like the unlearning boundary can be improved. And then conclude, just say that WMDP, of course, is not the end, but just the starting points for better evaluations of like dangerous capabilities of large language models. And if you are interested in the project and you want to learn more, like the paper, the code, and all the info are at the wmdp.ai. And yeah, thank you. I'm happy to take any questions.
Wonderful. Thank you so much, Alice. And everyone's welcome to clap at home, even though we can't hear you. And maybe I will just kick us off. So
Okay.
so we can think about the questions. I'm curious, Alice, how do you think about sort of setting the milestones for when it becomes catastrophically dangerous? If you are evaluating a model with a benchmark like this, do you think of it like, oh, when it's 70% capable of answering these correctly, that's very, very dangerous? Or where do you set that boundary?
That's a great question. So first of all, I think it's not just that, just setting like the threshold. I mean, it's not true that if a model answer like completely like super well to all the questions, it is dangerous at this point, but it just like tells you that the model has some capabilities related to that. So WMDP is not like enough to determine that. For sure, there are other like other measurements needed for that. So this is so I would not like say that the models that answer like 70% of questions is like super dangerous, but it gives you an indication of what the model can do. But WMDP itself at the moment it's not. I think it's not enough to determine like how a model can be like catastrophically dangerous.
Do you think that should sort of happen in combination with something like incident databases that can show real world examples of this risk, or do we want to capture it before in some way in a naturalistic environment?
Yeah, like maybe both. I would say. Also, I think that something that is also very interesting to analyze is like the real conversations or like analyzing open-ended questions. Like multiple choice questions are fine to assess the knowledge, but then also open-ended conversation can have a different different details that we cannot capture with just multiple choice questions. So yeah, I think this is something that we should keep in mind when doing these kind of evaluations, for sure.
Yeah, so you can end up with a type of propensity measurement as well for these dangerous executions.
Yeah.
Otherwise, while we are waiting, I think I can take Lucy's question. So
okay.
Do you have ideas of how this kind of work could be extended for other kinds of risks linked to the subject of the Democracy Hackathon, for example? So in this case, what might be some of the specific ways to maybe measure how it actually affects some of the real world risks?
Okay, yeah, that's a good question. So for the method, maybe a way to extend it is to like look at the internal representation on models related to persuasion or like deception. That can be maybe in this case you don't want to unlearn like completely, but you want like to steer the representations, the hidden representations of models. There is a online or research on that is called representation engineering, and yeah, where you play with the activation and you kind of steer the model where you want, so to be more or less deceptive or or honest, or there are many ways to do that by looking at the representation. This is something that it comes to my mind. And for benchmarks, that would be very nice. I think it's at this point, maybe you need, I need to think about that, but it would be interesting also to have a benchmark that measures like persuasion or like deception itself.
Alice, thank you for this presentation. I enjoyed hearing about your work on WMDP. My question's around the unlearning process. I imagine that other LLMs from OpenAI or Anthropic already have a kind of unlearning process for other kinds of worrisome content. For example, sexually explicit responses and so on. Do you think that your unlearning approach with RMU is important for removing this particular domain of content, or could it be integrated into the unlearning processes that are already being practiced in-house by some of these companies?
Yeah, that's a good question. So I'm not sure how. For sure, like companies, like providers of large language models, have some safety filters on top of their models. I'm not sure if they do something at the level of weights of large language. I'm not sure if they perform some unlearning techniques or they have filters on top of their models. But for sure, this can be. So, for example, let's say OpenAI can perform unlearning on a domain that they think to be dangerous, and then serving the model after that. This, in theory, wouldn't require any additional safety filters because the knowledge is not there anymore. This can be but I'm not sure if they are already doing that as unlearning, or they are having like filters on top of models. Indeed, like in the paper, we focus on closed source providers and like closed source large language models.
Yeah, thanks a lot. It was really interesting. I have I guess a bit of a technical question around how the unlearning approach compares to potential alternatives. So I assume that like really good dataset curation at the pre-training stage would be considered a somewhat analogous approach. Is it known like how well this would work in comparison?
I think for sure it would be like a good dataset curation would help with that, but it's very hard to like clean completely like the data sets, and I think there are also emergent capabilities of large language models. So maybe if the knowledge is not like directly there, maybe like a bits of bits of knowledge here and there can be enough. I'm not sure about that, but I think it could be a step for that. But in general, I think it's very hard to like clean your data set completely, and to be completely sure that there is nothing about the domain that you want to remove.
Well, thanks. Yeah, makes sense.
And we also have another question from David. who I invited to the stage as well. But
I was just also a question about the technique. Is this the unlearning technique? Is it fair to call it a type of ablation, or is it different from that?
I think it's more like acting at the level of representation. It's more like engineering the representations than ablation, I would say. Yeah, it's really like looking at the direction of the topics that you want, that you are considering, and try to steer these representations more than ablation, I think.
Thanks. I guess I have a follow-up question, which is, so this technique works for the output of models directly. Is there work that you're considering that would address like the use of models that would have tools for instance, like searching the web or referencing documents, that they'd be able to get knowledge from outside their own, what they have internally to themselves?
Yeah, I think that would be a great follow-up. So now, at the moment, I would need to think about how to do that, but this would be like for sure a great follow-up for the project.
Thanks.
Hi, thanks for the presentation. That was really interesting. So I'm just curious what the process looked like for creating this corpus of knowledge about things that you want the model to forget. Like who created that, and what was the criteria for determining what was included and not included?
Yeah, so for we talk a lot with experts about when we were collecting the corpora for Unlearning. So for bio, like the corpus is made of PubMed papers that focus on research about some topics that were suggested by our experts. So, for example, gain of function research or viral vector research. While for cybersecurity, again, we talk with our experts, and the corpus is made of text taken from GitHub repositories that have code about, for example, some exploitation techniques or topics that were suggested by them to be included in the corpus. So it's for cyber we have some GitHub repositories that contains code about topics that I suggested, while for bio it's PubMed papers that focus on specific research.
Okay, thank you. I'm curious, what is like the granularity that you're looking for in terms of forgetting? So for example, on the code, that makes sense. It's pretty clear. Like here's code, and if it's in there, get rid of it.
Yeah.
But for something a little more nebulous, like let's say gain of function research. So is it literally just like that term is something that you just don't want it to respond to, or is it something a lot more specific about gain of function that it should not respond to?
Yeah, I think it's broader. So since the corpus includes like the papers, it's more like all the knowledge surrounding that topics, not just the word like gain of function. So it's a bit broader. Should include like topics like connected to that, or what is explored in these papers, for example.
Gotcha. Thank you.
Wonderful. Thank you, Sam, for the great questions. And we have one last question in the chat that I'll read aloud. Is there any other example of benchmarks using an unlearning approach that you have mentioned, like something like this or a previous version? Or is this the first case in this type of area of risk research like this?
Yeah, so for specifically for like the cyber, bio, and chemical, I think this is like the first data set. And also for the method, I think this is the first one that removes entire domains of knowledge. There are some unlearning techniques that have been studied, but they mainly focus on like editing single facts, or they are focused on like privacy concern or like bias and toxicity, but not really on like unlearning harmful or unlearning domains of knowledge. So in our work we have some baselines, but it was really hard to like compare. We had to adapt like the baselines to these specific field of unlearning domains.
And I guess here, lastly, do you have any inspiring thing to say to the people coming here during this weekend who's going to spend their whole weekend doing some awesome AI safety research and try to make some concrete projects happen?
Oh, that's hard. Yeah, what I can say is just have fun and yeah, like focus on whatever you like. There are a lot of like interesting topics out there that are related to AI safety research, and really like have fun. And yeah, if you discover anything about WMDP, we would be very happy to learn some of these results, some of the follow-up questions that I mentioned before.
Wonderful. Thank you so much, Alice. And let's everyone give her another digital round of applause. So thank you so much.